Hey, what's up, guys? Hope everyone's having a great day, great Thursday. Today's going to be fun. We are going to be doing the processes section in the Elixir Getting Started guide. So this one's a lot of fun. It's going to be cool. We're going to be sending messages and stuff, I'm assuming, between processes. So get ready. And what's up, Daniel and Juan? Awesome to have you guys joining me live. And it looks like my chat isn't working today, but maybe it will start working in the middle of it. Sometimes it does that. And then sometimes it doesn't work. I think I have to find a better way to get chat working. I forget what I use, like Stream Elements or something, and it's just a browser window essentially, but clearly not very reliable. But anyways, let's go ahead and just jump right in and start this section. What is up, Chris? How's it going, Richard? Good you're here. Good to see you here. All right. Boom, boom. Screen shared. And let's get into it. Let's open up a Firefox window. We'll head over to elixir-lang.org. Let me make sure nothing's cut off here. We can go a little bigger. All right, cool. And we're going to just go over to guides and then the process section. All right, so processes. In Elixir, all code runs inside processes. Processes are isolated from each other. They run concurrent to one another and communicate via message passing. Processes are not only the basis for concurrency in Elixir, but they also provide the means for building distributed and fault-tolerant programs. Elixir's processes should not be confused with operating system processes. Processes in Elixir are extremely lightweight in terms of memory and CPU, even compared to threads as used in many other programming languages. Because of this, it is not uncommon to have tens or even hundreds of thousands of processes running simultaneously. So that's pretty cool. I think there's a popular blog post out there about like hitting 2 million processes, something like that, which is pretty impressive. In this chapter, we'll learn about the basic constructs of spawning new processes, as well as sending and receiving messages between processes. Yeah, cool. So we're going to have a lot of fun. This is going to be a good video, and you might want to follow along. All right, so spawning processes. The basic mechanism for spawning new processes is the auto-imported spawn arity1 function. All right, let's pull up our terminal here. Do I have the terminal open somewhere else? I do. Ignore that doc. All right. Let's clear. Let's get out of here. All right. Let's just start our IAX process. And we're going to spawn. So spawn arity1. It just is going to take a anonymous function from us. And all we're going to do is add 1 and 2 together and hit enter. And you'll notice when you do spawn, it returns a PID, which is a process ID. Let's go back. We probably talk about it shortly. So spawn arity1 takes a function which will execute in another process. Notice spawn returns the PID, process identifier. At this point, the process you spawned is very likely dead. The spawn process will execute the given function and exit the function and exit after the function is done. So yeah, if you are executing something that ends, the process will kill itself. Maybe that's not the best word, but yeah, it kills itself after it's done. And you can check to see if a process is alive by doing process.alive arity1, and then you pass in the PID. And so if we just do what we did before, but we'll save it to a variable so we can grab that PID easier. So we'll save it to a variable PID, and then we can do process.alive and pass in that PID. We get false because it quickly added it quickly executed this function and ended. So note, you will likely get different process identifiers than the ones you see in this guide. So yeah, they showed us 0.44.0 and we got a .10.0 and a .111.0. So it all just depends on what processes are running on your machine. And I heard a noise and we have a new subscriber. That's exciting. All right, back to the docs. So, all right, so we can retrieve the PID of a current process by calling self. So self is the process that we're in right now. So in this case, it would be our IEX shell, and that is our process ID. So if we run the same thing, process.alive, and pass in our current process, it's true. It is alive. Hey, good to see you. I'm going to butcher your name because I don't know how to speak any languages, but programming languages in English, but Dahoni, good to see you. And so you'll notice when I pass in, I should probably make this terminal a little bigger for us. So you'll notice when I pass in self, we get a true back. So our Elixir shell process is alive, so we get true. All right, processes get much more interesting when we're able to send and receive messages. So sending and receiving messages, we can send messages to a process with the send arity2 function and receive them with the receive arity1 function. So let's go ahead and run this example through. All right, and we're going to say, we're sending a message and it takes a PID. And in this case, we're just going to send self. So we're sending our process identifier. And then our message is going to be a tuple with an atom hello, and then our message world. And close off that tuple and that parentheses for that message. And we're going to hit enter, and we get the tuple that we sent. And then we can go ahead and do a receive here, and inside receive, we'll pattern match to hello and the message, and we'll just return the message that was sent, and we'll create another pattern, another case to match here, atom world, which we will not match here because our message we sent was an atom hello, and this won't match. And then we'll just end this receive. And right when we hit enter, it will receive the message we sent and return world to us. So that's pretty cool. So when a message is sent to a process, the message is stored in the process mailbox. The receive arity1 block goes through the current process mailbox, searching for a message that matches any of the given patterns. So receive arity1 supports guards and many clauses such as case arity2. And you can tell that we used case here. The process that sends the message does not block on the send. It puts the message in the recipient's mailbox and continues. In particular, a process can send messages to itself. If there is no message in the mailbox matching any of the patterns, the current process will wait until a matching message arrives. A timeout can be specified. All right, so if we were waiting for the message hello, so this message, the hello message, was already processed. It's gone, it's done. Our mailbox is empty. So if we do another receive, if we do receive and we do another pattern match here, and we're looking for the atom hello, and then we're going to return the message sent with it in the tuple. We can do an after. So after 1,000 milliseconds, we're just going to return a message that says nothing after 1 second, and then end. And then if we sit here for 1 second, it closes. So a timeout was reached for our process of receiving a message. And a timeout of 0 can be given when you already expect the message to be in the mailbox. So let's put together and send messages between processes. All right, cool. I think this stuff's really cool. And if you want to dive deeper into this stuff, I have glad to see you're working on this part of the doc. Oh, yeah, nice. I'm just working my way through the guide. And if you want to do a deeper dive, I have an awesome section in my Elixir, a Comprehensive Introduction course. And currently, because my birthday was yesterday, I have a 39% off discount code for anyone that wants to get it. There's 10 hours of content already there, and I'm still adding to it. But the processes and the concurrency and the OTP section, I go through processes, I go through gen servers, supervisors, all that fun stuff. So I highly recommend it. And that code is HBD 39. I almost said 29, and I had to remember that I'm getting old. It hasn't clicked yet in my brain. But all right, I'm going to clear this terminal. Thanks, Richard. Thank you. I'm going to clear the terminal just so everything's at the top. And let's go ahead and send some messages between processes. So we're going to have a variable called parent, and we're going to set it to our own process here. All right, and then we're going to spawn a function. So we're going to spawn a process that is going to send our parent process, which is us, a message of hello with our PID. So if we do spawn, and then we're sending in a function, or a function here, send, and then we're sending it to our parent PID, which is the Elixir shell, and the message is going to be hello, and then we're going to send it self. So we're just sending it our PID ID. And then we can go ahead and close those parentheses, end this function, and close that parentheses, and hit enter. And so now we have another process that is spawned. And if we go and now do our little receive block here, receive do, and we're going to pattern match to hello and return our PID. So we're going to return a message that says got hello from, and then we're going to concatenate, interpolate, not concatenate, interpolate our PID here, and we're going to use the function inspect. And inspect is just a function that will convert any data structure to a string so we can print it out in logs. So if we do that, I need a parentheses. Hopefully it lets me do that. And then we can end this, and we got our spawned process 112 from. So we sent, I got to explain this better. I feel like I explained this wrong. When we spawn this process, we sent a message to our parent PID, which is us, from the spawned process here. So self is inside of spawn. So we actually sent the PID of 112, which was our spawn process. So we sent a message from 112 to 109. And then when we did our receive block, it says, look, you got a message in your mailbox from 112. So that's pretty cool. All right, so the inspect function is used to convert a data structure's internal representation into a string, typically for printing. I feel like they said that better than how I said it. Notice that when the receive block gets executed, the sender process we have spawned may already be dead, as its only instruction was to send a message. While in the shell, you may find the helper flush arity1 quite useful. It flushes and prints all messages in the mailbox. So yeah, this is pretty cool. So if we're not setting up a receive block, we can send ourselves a message. So if we say send and then self, which is our PID, hello, and then hit enter, if I type flush here, which is a function, it's going to return all the messages in our mailbox. And our mailbox has one message, hello. And now that I flushed it, it is now empty and nothing will be returned. So that's pretty cool, I think. What is up, Connie? Good to see you. And thank you, Juan. I appreciate it. All right, moving on. Links. So the majority of times we spawn processes in Elixir, we spawn them as linked processes. Before we show an example with a spawn linked arity1, let's see what happens when a process started with spawn fails. All right, so back to our Elixir shell here. So if we spawn a process and we're just going to send a function in and we're going to raise an error. So raise oops and end. And when I hit enter, it's going to raise an exception. And let's go on. It merely logged an error, but the parent process is still running. That's because the processes are isolated. So what they're saying here is this process, the spawn 113, that's killed. It no longer exists. But our process is the parent. So if I type in self here, we're 109 and we're still 109. We were 109 up here as well. And that's important to know as we're going into this. So if we want the failure in one process to propagate to another one, we should link them. This can be done with spawn link arity1. So, all right, this is cool. I'm going to clear this again, and then I'm just going to say self here. So we see our PID of 109.0. And when we use spawn link, so instead of just spawn like we did before, we do spawn underscore link and we pass in our function just like before. And we're going to raise the error again of oops and then end and then enter. And so now when I hit enter, it's not only going to kill our process we're spawning, it's also going to kill the process that it spawned from, which is our Elixir shell. All right, so let's see. Our process raised an exception, and then you can also see that so two processes, this PID with 114 failed or crashed and exited, and then we have our 109 process, which was our Elixir shell, exited with the same error. So it propagated through all the processes that were like in a linked tree, essentially. So everything down, which is pretty cool. So if I do self now, we're going to have a new, so the Elixir shell also rebooted itself. So it recovered, right? But it's going to have a new process now. And so now our Elixir shell ID is the 115.0. So the 109 crashed and it recovered and we were still on our shell, but we lost our original process. Oh, you're hearing me twice, huh? That's not good. Let me see. Let me just change some stuff. Okay, how is that? Are you still hearing an echo? And our chat's still not working on the screen. Well, let me know, Potato, if you're still hearing a weird echo, because that's annoying. Let me make sure I'm not playing this stream in another window. What's up, Potato? It's not too bad anyway. Okay, weird. I'll have to worry about it. Maybe it's my room. I'll check it out after this stream. If it's not super bad, I'll just continue. All right. Now I forgot where I was. Okay, so we killed our own process. So because processes are linked, we now see a message saying the parent process. Oh, you know what? My audio's set up. Okay. Who knows? Live streaming's never easy. Could be a stereo thing. I didn't hear an echo, and I'm on one headphone. Yeah, it could be. Live streaming, man. It's always something. All right. Because processes are linked, we now see a message saying the parent process, which is the shell process, has received an exit signal from another process, causing the shell to terminate. IEX detects the situation and starts a new shell session. Man, these docs always say things so much better than I do. All right. Linking can also be done manually by calling process.link arity1. We recommend that you take a look at the process module for other functionality provided by processes. Processes and links play an important role when building fault-tolerant systems. Elixir processes are isolated and don't share anything by default. Therefore, a failure in a process will never crash or corrupt the state of another process. Links, however, allow processes to establish a relationship in case of failure. We often link our processes to supervisors, which will detect when a process dies and start a new process in its place. So while other languages would require us to catch and handle the exceptions, in Elixir, we are actually fine with letting a process fail because we expect supervisors to properly restart our systems. So failing fast, sometimes referred to as let it crash, is a common philosophy when writing Elixir software. And not to keep plugging my course, but I go through supervisors and how to use them in there as well. And it's super important because you can set up different strategies depending on what process you're spinning up. So you can either, let the whole line, you can let a whole line of supervisors and processes crash if one does, or you can just reboot the process that exited. So there's a lot of things you can do. And it depends on your use case to why you would want to let, a whole string of processes crash and reboot versus just rebooting the one that failed. So spawn arity1 and spawn link arity1 are the basic primitives for creating processes in Elixir. Although we have used them exclusively so far, most of the time we are only going to use abstractions that build on top of them. Let's see the most common one called tasks. Oh, I'm glad that we're doing like tasks, and what else are we doing? Okay, cool. All right, so tasks. Tasks are built on top of the spawn functions to provide better error reports and introspection. All right, so instead of spawn and spawn link, we can use task start and task start link, which returns a tuple with the second variable, the PID, rather than just the PID. This is what enables tasks to be used in supervision trees. Furthermore, tasks provide convenience functions like task.async and task.await, and functionality to ease distribution. I said that word. We will explore tasks and other abstractions around processes in the Mix and OTP guide. Okay, well, I think we should play with this example though. Oh, we're just raising an error. I see. Well, we'll still do it so we can get our tuple back. I'm on my AirPods and maybe I'm just hallucinating. It's all right, Potato. We all do. I hope you're hallucinating because that's an easier fix on my end. Oh, man. All right. So I forgot where we were. Tasks. Okay. So if we do task.start, and we start it the same way, we can pass in a function, and we're just going to raise an error here. Oops. And you can see we get a tuple back with our OK atom and then the PID ID as the second value. Okay. State. We haven't talked about state so far in this guide. If you are building an application that requires state, for example, to keep your application configuration, or you need to parse a file and keep it in memory, where would you store it? Processes are the most common answer to this question. We can write processes that loop infinitely, maintain state, and send and receive messages. As an example, let's write a module that starts new processes that work as a key value store in a file name kv.exs. All right, this is cool. Now I'm excited. I thought we weren't going to do any cool examples for a second when they had our task just show the response and the exit error. But this is fun. So we get to pull up, we'll pull up VS Code. First, we'll create a file called kv.ex. So I'm going to exit out of the terminal, not exit, Control C, clear. And I'm going to just change directories to my desktop. And we are going to make a file called kv.exs. So we're making an Elixir script. And now if we just open up VS Code, looks like we got a new update in VS Code. And then we're going to write our module here. So we're going to just create a def module, and we're going to call it KV. And what we're going to do is create a function that is going to start our task. All right, so def, and then we're just going to call it start link. And these naming conventions will make more sense as we get into gen servers and things like that, and supervisors, and what functions they require, like what a supervisor requires to start processes. And start link is one of them. And then inside of start link, we're going to do task.start link. And we're just going to have a function call our loop function that we're about to write. And our loop function is just getting past an empty map when we start it up, and then we just end that function. So all this does is start link is just calling an infinite loop. All right, so def p, we're making a private function here called loop, and it takes a map. And then inside, we're going to have our receive block. And inside of this, we're going to have our message type. We're going to look for, so get, we're going to be getting. We're going to be retrieving a value by its key. And we're going to call that, we're going to pattern match to get. So this is going to take a key and a caller. And then inside of this, we are going to send our caller. So the caller is the process that started this loop. So whoever's using it, in our case, it's going to be us. It'll be our IX shell. And so we're sending ourselves, or, the caller, a message back. And so inside of this, we're going to say map get, and then we're taking our map and looking for the key. Okay. So whatever key, we're returning them the value of that key. And then we're going to call, so this is a recursive function. We're calling our loop function again and passing our map back in. All right, so that's how we're going to get our keys. And then to put our keys, so this is going to add a key and a value. We're going to pass it a key and a value. And then inside of this case, we're going to call our loop function. So we're recursively calling loop, but we're just going to update our map here. So map, and then we're updating with the new key and value. So now our updated map is put back into our recursive loop function, and life keeps going. And so with receive is going to sit here and not call itself again unless it gets one of these messages. So receive kind of just sits as a process listening to our mailbox, right? All right, so let's go back to our docs and see what. So note that start link function starts a new process that runs the loop arity1 function. Starting with an empty map, the loop arity1 private function then waits for messages and performs the appropriate action for each message. We made loop arity1 private by using def p instead of def. In the case of a get message, it sends a message back to the caller and calls loop again to wait for a new message. while the put message actually invokes loop with a new version of the map with the given key and value stored. All right, cool. All right, so now let's give this a try. So if we go into our terminal now, and we're going to go into our IEX, we want to compile our kv .exs file. All right, and now if we want to start our link, but we want to keep track of our PID. So we're going to pattern match to the OK Atom tuple that comes back with the PID. So we're going to say kv.start link. And if you remember, when you start the task, it returns the tuple, not just the PID, because in our code, we're using task.startLink instead of just spawn like we did previously. All right, so when I hit enter here, we're going to get that process back, which is cool. And now when we can send this process, which is stored in our PID variable. We can say send, and then we're sending it to the 115 process identifier. And then inside here, it takes our tuple. And so we want to get, and we want to get a hello key. And then we want to send it back to ourselves. So we get the response. All right, just like that. And I don't think we're going to get anything back, right? Because we haven't put anything. We just have an empty map right now. Okay, so nothing is there. And if I hit flush, we get nil. So our mailbox is empty. So at first, the process map has no keys. So sending a get message and then flushing the current process inbox returns nil. So now let's send a put message. So we're going to do the same kind of thing, but instead of get, we're going to say put, and we're not sending anything back to the caller, right? Because the three variables, we have the put pattern we want to match, and then we have the key, and then we have the value, right? So our value is going to be world. And then when we hit enter, we get that back. And now if we call our get back now, let's go ahead and do that. Okay, so we sent a get, and you're probably wondering like, well, why didn't it return anything? It probably did. It's probably sitting in our mailbox. So if we call flush now, look at that. We have the message world sitting in our mailbox waiting for us. So that's really cool. I'm going to clear this, and then we'll go back to our docs. And notice how the process is keeping a state, and we can get and update the state by sending the process messages. In fact, any process that knows the PID above will be able to send it messages and manipulate the state. It is also possible to register the PID, giving it a name and allowing everyone that knows the name to send it messages. So registering it is really cool because it requires you to not know like the PID struct, right? The PID map, whatever you want to call it. It allows you to name it. So you can actually name things with, like in a real world example, you could name it like the module name with like maybe attach the user ID to it. So you always know what the name would be. But if it's like a dynamic situation where each user gets their own process created for them, you know how to look it up because you follow the same naming conventions. All right, so let's see. We're going to register a PID. So we have a PID right here, which is 115. And that is currently our state, right? That is the code we just wrote where we can still get a key hello from. So if we say process.register, we pass in that PID, and we're going to name it an atom. We're going to name it KV. Boom. All right, we get true back. So we successfully registered this process. And now we can send it messages like this. Instead of putting PID here, we can use the name of the process we just registered and now do get our key hello and send ourselves a message again. So boom, and now when I call flush, there it is. The world message is still there, and we use the name we registered instead of the PID. All right, back to our code, or the docs. So using processes to maintain state and name registration are very common patterns in Elixir applications. However, most of the time we won't implement those patterns manually as above, but by using one of the many abstractions that ship with Elixir. For example, Elixir provides agents, which are simple abstractions around state. Our code above could be directly written as, all right, so we wrote this code using a task, and now we're going to go back to VS Code, or no, we're going to go in our shell, and now we can just do an agent here, and an agent also returns a tuple with the OK and then the PID value as the second value. So if we do agent.start link, and also if you guys can hear that weed whacker outside, I apologize. And then we're going to just start an agent process here so agents are used for keeping very simple state. So all we're doing is passing in an empty map just like this, and this is the same thing that we just wrote in that KV script. So there we have our agent started, and then you can do things like this. We can just say agent.update, and we pass in our PID, and then we can say function, and then we have our map, and we can just say map.put, and then pass in our value map and say hello and update it with the value world and close that off. So what we're doing here is we're just inserting a key the same way we did for our KV script. All right, and then we can do the same thing now, and we can retrieve this item. So agent.get with the same PID, and then we're going through our map value, and then we're going to just say map get from our map that is the state of our agent, and we want to get the value of hello, and then we get world back. So same thing, just easier to use agent than creating our own process, our own process with task. So pretty cool. We walked through, real elementary starting processes, how to send and receive messages, and then we used task, and then we finished on agents, which I think is pretty cool. Let's close off the documentation here. So an atom name option could also be given to agent.startLink. So we can automatically register our agent like we did with our KV. Besides agents, Elixir provides an API for building generic servers called Gen servers, registries, and more, all powered by processes underneath. Those, along with supervision trees, will be explored in more detail in the Mix and OTP guide, which will build a complete Elixir application from start to finish. For now, let's move on and explore the world of I/O in Elixir. Ooh. So this is going to be fun. Yeah. All right. So in the future, at some point when we hit the Mix and OTP, we'll be hitting some Gen server stuff, supervision trees. Ooh, yeah, this is gonna be fun, guys. This is gonna be fun, and I guess we will end it on that note. And so that was our little taste of processes and how you can keep track of a simple state in your Elixir applications. So thank you guys so much for showing up. Chat still isn't working. Super bummed about that. But thanks a lot. And let's see, what are we doing next time? I got to find where I was. So next live stream will be on Tuesday, and we're going to do I/O and the file system. So that'll be cool. I will see you guys later. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.